For Finkelstein's reaction Rx, NaI acetone benzo, Ri plus NaX. So we have rearrangement. Reaction with HX, rearrange. Then halogenation of alkanes. Halogenation of alkanes, properties of alkanes. H alawa, major, minor. Yeah, major, minor. Halogenation of alkenes. Cl2H2O, Cl2H2O, or Br positive Cl negative, then Br2 CCl4. और इसमें क्या आएगा हेलोजनेशन ऑफ एल्केन्स में एंटी एडिशन from halogenation of alkenes already done in properties of alkenes. From hydrohalogenation of alkenes already done properties. Okay, we have HCl peroxide, HCl peroxide, HBr peroxide, alkane. So Br the फर्क बनता है पर Cl the फर्क नहीं बनता. Halogen exchange Finkelstein reaction Rx with NaI acetone benzo, Rx with NaI acetone benzo, Ri plus NaX. X हटाओ, I लगाओ, no rearrangement. There's no rearrangement in this. No rearrangement. Finkelstein's reaction Rx acetone benzo and NaI. Schwarz reaction Rx EGF, Rf plus EGX, Rf plus EGX. Other reagents COF2. We have other reagents COF2. Ball-Streeman reaction. Okay, then we have Finkelstein's reaction Rx NaI acetone DMSO dimethyl sulfoxide, RiNaX acetone dimethyl sulfoxide. Schwarz reaction COF2. Schwarz reaction with AgF COF2 SbF3 Hg2F2. Schwarz reaction with F SbF3 Hg2F2 CO. No rearrangement Rf. No rearrangement. Schwarz reaction, no rearrangement. Next we have haloarenes, method of preparation of haloarenes. Method of preparation of haloarenes, electrophilic substitution reaction. Haloarenes X2 with FeX3, X लग जाएगा एक, X2 with FeX3. From aniline pH NH2 NaNO2 plus HCl, NaNO2 plus HCl diazotization pH N2 Cl negative, NaNO2 HCl 0 to 5 degrees Celsius, NH2 हटाओ, N2 Cl negative लगा. Then we have Sandemir's reaction pH N2Cl with Cu2Cl2 PHCl HCl, Cu2Br2 HBr PHBr, Cn CuCN KCN PHCN. For Gattelmann reaction N2Cl, Cu and HCl PHCl, Cu with Br PHBr. Sizig's reaction N2Cl with I and Ki PHI. Ball-Streeman reaction with F negative HbF4 PHF. Properties of haloalkanes nucleophilic substitution reaction Rx with nucleophile X will be replaced by Rnu. SN1 unimolecular nucleophilic substitution Rx. Redetermining step 1. R positive plus X negative Rnu. Carbocation formation, rearrange if possible. Formation of first carbocation is the rate determining step. Carbocation formation, rearrangement if possible. Rearrangement if possible. Formation of first carbocation is the rate determining step. Rate of reaction R is equal to K. Rx molecularity 1 order 1. Rate of reaction is directly proportional to stability of first carbocation. Rate of reaction iodine, bromine, chlorine, F. Stereochemistry R1, R3, R2, X rate determining step. Optically active alkyl halide. E and B are enantiomers. Racemic mixture SN2 bimolecular nucleophilic substitution. N2Rx lower rate determining step. Nucleophilic bond formation or bond breaking X. NUR plus X negative. First step reaction SN2 no intermediate formation, only transition status formed. Rate of reaction is inversely proportional to steric hindrance. Primary, secondary and tertiary. Rate of reaction Ri then Br Cl F. Rate of reaction R K Rx Nu. More molecularity 2 order as 2. No rearrangement. Stereochemistry of SN2. Optically active alkyl halide. Walden inversion. Reagent NaOH. SN2 will be NaOH. SN1 is H2O. These are all added to Rx. Added to Rx. When NaOH is added, X हटाओ बच लगा alcohol. H2O. SN1 reaction करेगा alcohol. NaOR NaOR RO negative SN2 ROR. Then we have ROR ether. NaI is also NaOR ether ROR. X हटाओ OR dash NaI RI alkyl iodide with NH3 Rx with NH3 R NH2 primary amine, then secondary amine and tertiary amine. These are amine are SN1 reaction KCN AgCN KNO2 AgNO2. जो भी AgNO2 या AgCN आएगा तो उल्टा हो जाएगा. SN2 reaction isonitrile alkyl nitrile nitroalkane ester RCO silver RCOO negative SN2 reaction ester LiAlH4 H RH hydrocarbon Rx with LaH it will form hydrocarbon. Hydrocarbon R dash gives M positive R dash SN2 RR dash alkane. Rx with KCN. Comparing SN1 rate law unimolecular substrate only Rx, bimolecular substrate and nucleophile Rx Nu. Big barrier carbocation stability, steric hindrance alkyl halide or electrophile 3 degree, 2 degree, 1 degree is the worst. Nucleophile weak and strong, generally bearing a positive charge. Solvent polar protic alcohols and polar aprotic for SN2, benzo and acetone. Stereochemistry mixture of retention RM and inversion only. Solvents polar protic HOH ROH RCOO H polar aprotic. ऑक्सीजन से H नहीं जुड़ा होगा. एसीटोन पोलर aprotic for SN2. O से H नहीं जुड़ा होगा. पोलर aprotic. स्टेरिक हिंड्रेंस हो चुकी है. कार्बोकेटाइन स्टेबिलिटी टेम्सो डाइमेथाइल सल्फोक्साइड DMF. Effect of solvent SN1 reaction polar protic favors Rx. Redetermining step is slow. R positive plus X negative. Nu negative R minus then R Nu. SN2 reaction polar aprotic favors NaI, Na positive, I negative. More repulsion, more nucleophile, more reactive. Nucleophilicity, ability of nucleophile. Negatively charged nucleophile is more nucleophilic than corresponding neutral atom. So nucleophilicity का किया काम negatively charged nucleophile is more nucleophilic than neutral atom. OH OH more than H2O. If donor atom is same or belongs to same period, left to right, nucleophilicity decreases in polar protic solvent and increases in polar aprotic solvent. Polar protic solvent and polar aprotic solvent. Like polar protic solvent like CH3, Sarna highest, then NH2OH, then F. CH3, NH2OH, F negative, BAS. In polar aprotic repulsion, in polar protic solvent, there is solvation. Size carbon में ज़्यादा है than F. Charge density F थी ज़्यादा है, repulsion F था ज़्यादा है. But nucleophile F है, solvation F है, the nucleophile H है carbon ion. The donor atom is same, nucleophile is same as basicity. In polar protic solvent, CH3, CNOF. Along the period, nucleophilicity decreases. For polar aprotic, along the period it increases. Top to bottom nucleophilicity increases in polar protic solvent and decreases in polar aprotic solvent. Repulsion, polar protic चाहिए, solvation, again repulsion and solvation. If lone pair containing atom present adjacent to nucleophilic atom, then it will be more nucleophile. वही RX with सारे G arrange रहने पड़े. Nucleophilicity is inversely proportional to steric hindrance. Polar protic solvent. Polar protic solvent SN1 versus SN2 polar aprotic. 3 degree SN1, 1 degree RX SN2, 2 degree RX, both SN1 and SN2. Strong nucleophile negatively charged SN2, weak nucleophile neutral SN1. Identify the type of reaction. One, two, three. 3 degree, that is SN1. SN1 and SN2 reaction. SN1 solubilizes, where solvent itself acts as nucleophile. SN2 reaction, strong nucleophile वाले. KOH, NaOH, KCN, NaCN, AgCN, AgNO2, KNO2, NaNO2. H2O hydrolysis, ROH alcoholysis, and acetylysis. Silver वाली reaction, formation of carbocation, Ag2O, AgOH, AgNO3. Three ring. So carbocation की stability तो चाहिए ना. Carbocation formation SN1 जाएगा carbocation का formation. Rearrange if possible, formation of first carbocation formation, rearrange चाहिए steric hindrance, no rearrangement. SN2 SN1 rate of reaction is directly proportional to stability of first carbocation. First carbocation बनेगा 3 ring, so resonance 2 ring का resonance, 1 ring का resonance, ऐसा ना ज़्यादा. Following reactants do not give nucleophilic substitution reaction. Reactant के लिए vinyl halide, phenyl halide, halobenzene, and bridge-headed halide. Due to partial double bond character, accelerate according to Brett's rule. E2 already done in method of preparation of alkene. E2 is already done in method of preparation of alkene. अल्फा बीटा एलिमिनेशन अल्कोहलिक KOH मेजर माइनर ते एक्वस KOH यानी कि SN2 रिएक्शन even CV already done in method of preparation of alkene again major minor even CV फ्लोरीन वाला किया अल्कोहलिक KOH even CV reaction with metals Wood's reaction with metals Wood's reaction reaction with metal Wood's reaction RX with sodium and diether obviously reaction with metals Wood's reaction RX sodium with diether RR Wood's fatigue sodium with diether RPH fatigue reaction PH Ullmann reaction PH with I copper and heat leaving ability RX nucleophile R nucleophile leaving group stronger is the conjugate acid better is the leaving group leaving ability किसी साना चाहता है I Br Cl F H positive है चार्ज किया HF HCl HBr I strongest is the conjugate acid better is the leaving group bond energy decreases down the group leaving ability bond energy decreases leaving ability down the group लीविंग कंपेयर लीविंग एबिलिटी H पॉजिटिव दोनों चार्ट करो CH3COH और CH3 एसिडिक स्ट्रेंथ SO3 with CH3 SO3 with CH3 and SO3 with NO2 nosyl tosyl prosyl triflate mesyl SO3H TNBD mesyl tosyl mesyl prosyl triflate and mesyl BCADE is I don't know so B that is nosyl acidic strength nosyl brosyl tosyl triflate and mesyl एसिडिक स्ट्रेंथ आ गया ना NO2 वाला पहले NO2 फिर ब्रोमीन NO2 ब्रोमीन टॉलुईन यानी कि CH3 then TR that is triflate CF3 and mesyl CH3 CF3SO3 CF3SO3H CH3SO3 CH3SO3H NO2 bromine toluene then then this is CF3 and CH3 paratolulyl sulfonate nosyl is para-nitrosulfonate brosyl para-bromosulfonate triflate trifluorosulfonate and methyl sulfonate properties of haloarenes nucleophilic substitution reaction no reaction of nucleophilic substitution reaction reason due to partial double bond character between C and X due to instability of phenyl cations PHX partial double bond character due to difference in hybridization of carbon of CH bond due to repulsion between nucleophile and electron rich haloarenes those processes Cl लग गया NaOH 623 Kelvin 300 atmosphere pressure and H positive OH phenol Cl हटाओ, OH लगाओ. In the presence of electron withdrawing group like nitro, nucleophilic substitution occur. Ortho-para substituted nitro-halobenzene can give nucleophilic substitution reaction. Cl with NO2, NaOH and H positive. Cl हटाओ, OH लगाओ. Nitro, electron withdrawing group. Cl with NO2. Ortho-para substituted nitro-halobenzene gives with NaOH gives OH. Nucleophilic substitution reaction. Mechanism: O-chlorovenzene, NO2 electron withdrawing group, OH will attach to this point. sp3 hybridized, negative further chlorine, fast reaction, aromatic. Carbanion is stabilized by NO2 group. Metanitrochlorine, either negative here. Carbanion is not stabilized by NO2 group, not possible. Para-nitrochlorobenzene, again NO देता गया, NO देता, इधर नेगेटिव को आ गया, इन्हें वापस NO देता, इधर गया, तो क्लोरीन निकल गया. Carbanion is stabilized by NO2 group. Mesenhymer complex है Cl, OH and NO2 mesenhymer complex. Oppenheimer, also known as aromatic bimolecular aromatic substitution reaction, nucleophilic substitution reaction. Rate of reaction is R. Orthopara and nitrohalobenzene and OH negative. Order is 2, molecularity is 2. Rate of reaction, stability of carbanion, directly proportional to number of NO2 groups. Rate of reaction, F, then Cl, then Br, then I. pH F, but usually हम की पढ़े हैं pH F सबनो ज़्यादा, then Cl, then Br, then I. If NO2 groups are same. ROR, stability of carbanion, directly proportional to number of NO2 groups. F, Cl, Br, I, but otherwise it is R. I, Br, Cl, F. Two step. First step is slow, second step is fast. NO2 Cl with NaOH. रिएक्शन कौन करेगा, Cl या F? दोनों X है, F करेगा. Electrophilic substitution reaction, always para is major. Always para is major. X orthopara directing minor, X is equal to इतना major, इतना major, इतना major. Orthopara major, ये ज़्यादा है than this. Electrophilic substitution reaction, always para is major. Always para is major. Halorine, minor and major. Rate of reaction of benzene is more than halorine. Chlorination, X with Cl2 and Fe. Already X लगे था, Cl. Minor, major. Para is major. Nitration. Nitration X. NO3 and H2SO4. NO2, NO2. Major. Sulfonation, SO3H, SO3H. Friedel-Crafts alkylation, R and R. Friedel-Crafts acylation. No rearrangement. Friedel-Crafts alkylation, rearrange if possible. When we come to Grignard reagent, Method of preparation of Grignard's reagent RxMg 35 degrees Celsius dry ether RMgX with dry ether